All our attendees at yet another webinar Wednesday showing how we leverage the power of technology. First of all, the truth is that we are in two different studios today, Melissa's studio and my studio. We are in two different buildings today, one in Mequon, Wisconsin, the other one in Florida. We have two different pieces of equipment being utilized today, one here at our tech center in Mequon and one at the Levil headquarters in the state of Florida. So really leveraging how we can spread technology across geographically, across technologies to bring great content to all of you in the world of technical education. I'm going to begin with this, and that is, as most of you know, I love manufacturing. I spent my entire career there. I love manufacturing. I love everything about it. I love the thump, thump, thump of a stamping press in a manufacturing facility. I love the whir of a machining center as a tool cuts through metal. I love to hear that hum of a hydraulic lift as a powder coating operation moves racks and racks of parts from tank to tank to tank. The rattle of a mechanical finishing bowl, the grace of a robot, the engineering behind a conveyor system, looking over my shoulder for an approaching fork truck, or for that matter, looking over my shoulder at the end of the day to see the fruits of my labor, the parts that I was able to produce. I love the smell of cutting fluids and surfactants in manufacturing. I love the people who work in manufacturing, living out the American dream in America and across the globe. And most of all, I love the evolution of manufacturing technology. Manual mills and lathes giving way to screw machines, to CNC machining centers, 3-axis machining centers, 4-axis, 5-axis. Think about how far our manufacturing technology has come in just the world of subtractive manufacturing, commonly called machining. And that technology continues to evolve as we use smart sensors and smart devices and gather information from our machining centers in real time, enabling us to predict future failure, predict future issues, and avoid them before they ever happen. I also love additive manufacturing, printing parts in metal, printing them in composites, in some cases stronger than aluminum, printing work holding technology, fixtures, end-of-arm tooling, and more. What happens, though? What happens when technologies like additive manufacturing converge with the world of subtractive manufacturing? And that is the topic of our webinar today. Here joining me are two people for whom I have a great deal of respect. We will start with the gentleman on the left. Ricardo Leon is the sales and marketing manager for Levil Technology, where he has been employed since 2017. He took an interesting route into the world of manufacturing. He graduated from Lincoln College with a bachelor's degree in restaurant management and hospitality, showing us that there is a place for everyone in manufacturing if you understand technology, if you want to be part of the American dream. He says that one of the greatest things about working at Levil is the fact that he gets to work with amazing people, but always meet new people every single day. His hobbies are cooking, traveling, and most important, as those of you who know him, flying. And so, Ricardo, it's wonderful to have you on, and it's wonderful to have Andres Leon as well. Now, Andres and I actually got to know each other in Tokyo, Japan, about 4 or 5 years ago. Fascinating person. He's been at Levil since 2008 as a machine operator and a machine assembly technician to begin with. He now serves, as I mentioned, as the general manager. He learned from his father as he completed his studies at UCF in, get this, aerospace engineering. These are two very, very smart people. As the general manager, he's involved in research and development, customer and partner relations, and overseeing the production processes at Levil. His interests include traveling, camping, scuba diving, relaxing on the beach when he is not supporting the Levil team. But today we are so glad, Andres, that you are here to support us and our attendees at Webinar Wednesday. So to Ricardo and Andres, both welcome. We're so glad to have you here. And Ricardo, we are going to start with a question for you. As our audience gets to know the EDU Mill, can you talk about how it is appropriate, both in high school labs, in career technical education, and fab labs and maker spaces? What are the different applications and who would use a product like this?
Awesome. Well, first of all, thank you so much for the invite. Thank you for the introduction, actually, as well. We are very excited to be here today. And we are really excited about the introduction of our latest machine, the EDU Mill, which is a great machine for high school, technical school, fab labs, CTE, just because of the fact that you can easily change from additive to subtractive manufacture in just like less than a couple of minutes. And that's something that we have looked into in the past, and now we finally have it. And not only that, we are integrating what it's called the metal 3D printing, which we're gonna get to it in a little bit down the road. But it is very exciting just because the machine is very small, capable. You can do milling machining, you can do 3D printing, you can do metal 3D printing. So there's a wide variety of stuff that you can do with the unit. And not only that, it's compact enough, and it also has a industrial controller such as the FANUC controller. So for students and kids or high schoolers or even university, they can learn how to use these controls that are everywhere, I will say, in the United States and also around the world. And it's also one of the most commonly used controls in the world. So it is the fact that you can learn on one of these controls, it's a big plus, especially when you go out in the industry.
So certainly huge value. And in fact, our two companies got to know each other through our collective relationship with FANUC. As you suggest, Ricardo, FANUC is by far the most prolific CNC control in manufacturing. I don't care what state of the country you're in. I don't care what continent you are on. If you walk into a manufacturing facility, you are going to see FANUC CNC controls. And as we know, those are found in a wide variety of equipment, including on the EDU mill. So I'm so glad that you mentioned that, the ubiquitousness and the fact that we're using a industrial grade control that students are going to see when they get to industry. So even if they're doing perhaps a project in a fab lab, it is absolutely authentic industrial technology. Now I'm going to stop sharing the screen here, and I'm going to turn the discussion over to the rest of our team as we ask a few questions about the technology specifically. And Ricardo, we are going to start with a question for you. Let's take a look at the EDU mill in action here at our tech center in Mequon, Wisconsin. My colleague, Mike Dietrich, our Vice President of K-12 and Training, has set up a part that is ready to be milled. And while we watch the machine at work, can you tell us a little bit about the machining capabilities of the EDU mill?
What you're looking at right now is the EDU mill. It's cutting it's cutting aluminum. The spindle that it's working on is a 2.2 kilowatts, and it runs 24,000 RPM. And it uses ER20 tapers. It's a ceramic variant, and it works on 220 volts. But we do have a stepper down transformer for all those schools that use 110. So that's one of the very important things of the machine. You can connect it to 110 volts, so you can literally move it around and connect it anywhere in your either office, kitchen, school, classroom, whatever you want to plug this machine into, you can. So we make it easier for you. One of the most important things of this machine is that it can fit through a standard doorway. That brings a lot of value to this machine, just in case, because there's a lot of people out there that have no space in their classroom, or they would like to do it like, or they do it like kind of like in the middle of the semester, and maybe having a machine right in the classroom can occupy a lot of space. So that's one of the big plus of the machine. It's very lightweight. It's about 300 pounds, and that includes about 400 with a table. The machine uses a servo control on all axes, and it uses C7 ball screws, so it's very precise machine. It has if you can see it in the back, there it has a 2-lens sensor, the high-speed spindle, and with, like I said, we are optional. As an optional, you have the FDM or fuse deposition modeling for the 3D printing, which we can do dual head or single head. One of the important things of the machine, the workable size of the machine is 16.8 by 9.8 inches, which is very important. It's a small machine, but very capable. The travel for this machine, you're looking around 7 inches on the x-axis, 10.5 inches on the y-axis, and 7 inches on the z-axis. And the accuracy of this machine is 0.10 microns.
So absolutely tremendous capability packed into, as you suggest, a tremendously small package, being able to fit that in through a standard doorway, 300 pounds, FANUC control, in a high degree of ability to hold tolerance and a high degree of precision certainly for a machine of its size. So really impressive engineering going on here as we're watching the control and the code running on the left side of our screen and actually watching the milling process on the right side of the screen. So I want to turn our discussion now, Ricardo, to your colleague, Andres, and talk about some of the capabilities, additional capabilities of this machine. Now, Andres, you're at Leville's headquarters and you've got your own EDU mill running there, as I understand, set up for milling. Is it difficult and is it time consuming to make the transition from machining, which we're doing now, to 3D printing, which we'll see in a moment?
Hi, everybody. I'm a little off camera right now. I'm going to be working on the EDU mill, but to answer your question, Matt, no, it is not difficult at all to do the switch. If actually, I'm going to run through it. Basically, we start by removing the work holding fixture or the vise. You know, you remove your screws, take the vise out. You know, that's the main part. Once you have that done, then what you do is you grab your 3D print head right here, and it just mounts right in with some magnetic hooks, and it's on right now. Then we're gonna come over here and just grab the wires that are hiding in place so they don't get dirty when you're doing the machining. You take them out of their box, connect them. You have the 3D print head already connected. The next step would be to grab your heat bed right here, which is also magnetically attached to the table. And then you just grab the cable for the heat bed, which is also hiding, connected, and you are set for 3D printing. One last thing I'm gonna do is I'm gonna grab my spool of metal material, and this is actually stainless steel, 316 stainless steel, that I'm gonna start printing with right now. So I'm gonna grab my material, I'm gonna load it into the extruder, and I am set. I have switched from a CNC milling machine system to a 3D printing system. So I got my program ready, and I'm going to cycle start the system. All right, so right now the machine is just heating up, the extruder is heating up. Once it hits the correct temperature, it will start printing.
As you can see, you may say it's a small machine, but it has a lot of mass built into it. It has a granite body and also a stainless steel enclosure. So it helps reducing a lot of what is the vibration and brings a lot of precise into the end part.
That looks so easy that I think even a webinar host could do it. That was really impressive. And look at the engineering that goes into as far as the transition from a subtractive manufacturing machine to an additive manufacturing machine. Andres, who would have guessed when you and I were together a few short years ago in Japan that by the year 2021, we would be talking about 3D printing using stainless steel. It's just incredible, the innovation. Tell us a little more about the capabilities from a 3D printing standpoint on the EDU mill.
So for the FDM style 3D printing technology, we can do most of the materials as long as they are within the melting point is 300 degrees, and it's 300 degrees or less Celsius. And the material that we use is 1.75 millimeter diameter. So that has to be the filament diameter that fits into our extruders. And then material wise, we have your basic PLAs, ABS, PTEG. We have done tests with TPU, so the flexible materials. We have used nylon infused carbon, PTG infused with carbon. And right now, as you can see in the video, we are doing metal 3D printing. So this is the latest technologies that we added to our machine. And the types of materials that we can do at the moment are aluminum, stainless steel, brass, bronze, copper, titanium, Inconel, and there are some ceramics. We have yet to test those, but those are available as well. So those are the different styles of materials that you can do in our machine. And it doesn't stop there. As long as there's a material out there that fits the parameters of the machine, so under 300 degrees Celsius melting point and 1.75 millimeter diameter filament, you can put that in our machine and it will print it.
Just an amazing number of different applications, different materials, and your mind almost runs in terms of all the different types of parts that one might be able to create using technology like this. So again, really, really impressive on the engineering front. Now, I know one of the questions that our audience is going to have, Andres, is once this print is complete, once we're done laying down the material on the print bed, is that part ready to go, or is there some post-processing that needs to take place as well?
So no, that part is what we call a green part. So it is in a clay-like state. And here, I'm just gonna move the camera around. I'm gonna put right there so we can look at the kiln system. This is what the post-processing will look like. And the part that we're printing right now is this right here. It's an impeller. This is in stainless steel, so same material that we're printing right now. If I were to grab this and try to break it, it will break because, like I said, it's in a clay-like state. So after this, the machine finishes printing, what we need to do is we need to heat up the material up to a certain temperature to get rid of the plastic that's inside. So this is stainless steel mixed with PLA. We debind the PLA, so the PLA goes away, and then we heat it up some more to fuse all the stainless steel particles together. The way that process works is you put your part in here. You're gonna add some material, which is refractory material. You add some in there. You make sure that you cover it really well, the part. Then you put it in your kiln, and you set it up. Depending on the material, you have to set it up the different temperatures and different times, heating times. So it takes about 5 hours for the debinding process. Then once that process is done, you take it out, and then you add this carbon powder, which is to help you keep the oxygen away for the sintering process. So you put some carbon powder in there, you put your part back, and then you sinter it. And this part, depending on the material, it takes between 5 to 8 hours for finishing. Once the part is done, you take it out, you remove it, and then you polish it as required, and then you have a true 100% metal part. Over here, I have a sample. It's a little robot. This is the green part, and this is the actual sinter part. And this part, I'm gonna drop it right now. Right there, it dropped. I pick it up again, and it's still in one piece. So nothing happened to it. So it's a really strong part. And that is the process that it takes to make a fully metal part for using our 3D printing machine.
So literally 10 to 13 hours after it comes off of that print bed, we have a fully functional 3D metal printed part in a wide variety of different materials. So very, very impressive. Now, I know, Ricardo, as we turn our discussion over to you, I want to talk a little bit about the EDU part of the EDU mill. The truth of the matter is that you put EDU right in the middle of the name of the product, certainly for a reason. It is a great product with awesome applications in the world of education at every level of education, as we talked a little while before. So now that we've seen what this equipment is capable of, provide an example or two, if you would, of how a school might use both subtractive and additive manufacturing components in a single project.
Absolutely, and I'm glad you asked. The EDU mill, well, we named it the EDU mill only for educational purposes, but it can also be used in the industry, and not only as just to make simple part or make metal 3D printing, but also for prototyping. One of the very important things, for example, this part that we are making right here, you require a full 5-axis machine in order to do this. With metal 3D printing, you just will 3D print it, and then what we do is sintering, and we do have the same part that will take probably a lot of knowledge to do on a regular 5-axis milling machine, which it can cost probably over $200,000 or $300,000 just to have a 5-axis machine. We're able to make it for a reasonable price, and also very, very quick, and not require as much. And you still learn everything that it goes from the FANUC control and all that stuff, but you do have a less process to do.
So I could see applications in, for example, a FIRST robotics team, certainly in a fab lab, maybe
Yes.
even in an art class, certainly on the tech ed side and CNC. I mean, just tremendous STEM and manufacturing applications for this technology, from the design all the way to the manifestation of the physical part. I can't say enough about how impressive the technology is, how impressive these parts are. I know our audience has been impressed as well. And Melissa, I think it's about time for us to turn our sights to the audience and see what types of questions have rolled in during the course of our discussion this afternoon.
Absolutely. Thanks, Matt. And again, to all of our attendees on live with us, as we roll into a time of Q&A, if you do have any questions that we didn't answer during the presentation portion, please do submit those in that Q&A box. The first question that came through here is, you mentioned a 10 micron tolerance. Is that for the machining portion, the 3D printing, both? What is that exactly referring to? Can you talk more about the tolerance?
That is mostly for the CNC part of the for the machine. When it comes to 3D printing, it's kind of it's very difficult to measure those tolerances. It depending on the material, depending on the extrusion and all the stuff. So the precision might vary depending on what material as well you are using.
So let me cut in there really quick. So the machine will give you that precision, whether you're CNC machining or 3D printing. But when it comes to extruding the plastic, because of the properties of the plastic and how it behaves, it's very tough to maintain that precision. So that the error goes up more than the 10 microns.
Perfect, thank you. We've had actually a couple of people ask the same question, but is there proprietary software to use for the CAD or the CAM for the 3D printing?
So no, there is not a proprietary software. We are using at the moment a Cura software, and we have set it up so it outputs the G code exactly how the final control wants to read it. So we provide that with all the machines for the user to start using the machine right away.
Perfect, perfect. Andres, another question for you. Does the unit auto level and auto calibrate that first layer?
It does not. So that first layer needs to be calibrated beforehand. And once you calibrate that, it stays, it will maintain the specs over time, as long as when you calibrated the machine and when you're using it, there's not a big change of temperature, because as you know, temperature changes the length of material. So as long as you're in a temperature controlled room and you do the calibration, then the bed will stay level.
Perfect. All right, now this participant says we don't use FANUC controls much. Is there a resource that I can use to learn FANUC controls?
Sorry, can you repeat the question again?
Sure, and Matt, you know, you're also welcome to answer any of these questions as well.
Sure,
but
you want me to jump in on that one, Melissa?
Yeah, go ahead.
Yeah, absolutely. So the question, Ricardo, that I'll go ahead and answer, and you can let me know if you have anything to add, is it sounds like the participant said they don't use FANUC controls currently. If they were to purchase the EDU Mill, how would they learn the FANUC software, the hardware, the use of the control, and so on? The answer is there are a variety of solutions. One of our favorites is CNC Concepts. So if you know Mike Lynch, who writes for Modern Machine Shop, he's a well-known person in the world of machining. Mike came out with a product a number of years ago called CNC Concepts, which does a great job either on an e-learning platform or with written curriculum for teaching students that FANUC CNC control. I can also tell you that most of your technical and community colleges will have courses around that technology as well. So some really, really good solutions. And there are others, but those are the two that we would feature this afternoon.
I wanted to add, Matt, to your answer. It's also referring about Mike Lynch is also doing a curriculum for 3D printing and metal 3D, which is top of the line. We are taking the class as well to make sure everything pairs with our machine as well, and in general in 3D printing. So that's something that is coming out soon, and I just wanted to point that out.
Great, thank you. Back to you, Melissa.
Perfect, thank you. I know that you mentioned a little bit earlier, Ricardo, some of the specs of the machine, but can you repeat again for our audience, particularly those with a smaller footprint or who need this, you know, the mobility? Can you talk a little bit more about the weight, the mobility of the machine, and some of the power requirements?
Absolutely. So the machine weighs about 300 pounds. Just the machine. If you add the stand, it's about 400 pounds. And the machine fits through a standard doorway. So it's about 32 inches, if I'm not mistaken, wide, and it's about 72 inches tall.
Excellent. And another question that came through, which I know a lot of people ask as well, is this proprietary filament or needs to be ordered specifically through a specific vendor, or can you use any filament for the 3D printing?
So you can use any filament as long as it fits. It has the 1.75 millimeter diameter. You can use the filament. Do keep in mind though that different manufacturers make their filaments differently. So some might work better than others. Some might not work at all. It just depends on how well the filament was made. So if you have companies that you have used in the past, and you have good results with their filaments, those should work just as well in our machine.
Great, thank you, Andres. All right, it looks like we've covered a whole bunch of audience questions. Audience, thank you for submitting those. Matt, I will leave it to you to wrap up.
All right. Well, thanks, Melissa. I can't agree more. What a great group of questions from our audience. Truly, people are really, really engaged with this technology. So thanks so much for the participation there. We're going to wrap things up here on this edition of Webinar Wednesday. But before we do, I want to be sure to thank our two guests today, Ricardo and Andres Leon, just great partners of Levil Technology and really showing off some fascinating innovation that's taking place there at Levil. We're proud to be partnered with them here on Webinar Wednesday. Really appreciate both of you joining us. Thanks so much for the insights. Teeing up our topic for next week, we're staying on a little bit of a FANUC topic. We are going to talk about FANUC robotics and specifically their relationship with NACD as it relates to certifications in robot operations, programming, and beyond. So for any of our cert schools across the Midwest, across the United States, for anybody interested in teaching FANUC technology, if you want to become more familiar with how we certify technicians and operators on the most widely used robots in industry, next week's edition of Webinar Wednesday will be one you don't want to miss. And we will be back here next Wednesday, as we are every Wednesday at 2 o'clock. We will see you then.